Okay, so now we're moving on to perfect squares and we're making that connection. So I have drawn out, so you'll notice I have numbers 1 to 9 all written out. And then I've drawn out the possible combinations for drawing rectangles for numbers from 1 to 9. So what I want you to notice is 1 has 1, use a different color. 2 is a 2 by 1, 3 is a 3 by 1, 4 has a 4 by 1 and a 2 by 2, 5 is a 5 by 1, 6 by 1, 3 by 2, 1 by 7, okay, 8, 1 by 8, and a 2 by 4, right? 2 multiplied by 4, right? Is a 1 by 9, and then I have a 3 by 3. Okay, so I have these all drawn out. Which numbers is of the rectangle, which numbers can you find squares for that make squares? So if you look, I'm just going to circle them here. There's a square, there's a square, and there's a square. So I have the numbers 1, 4, and 9. Okay, so what are the sides of those squares? So this one here, this is a 3 by 3, this is a 2 by 2, and this is a 1 by 1, right? And now I just want you to think about those numbers. Okay, 1, 2, 3. These are all whole numbers. Okay, it's not a fraction, it's not a decimal. Okay, these are whole numbers greater than 0. Okay, so what I'm going to say now is what I have found. I have any number that's larger than 0. So I found all these numbers that are larger than 0 that can be multiplied by themselves. See, 3 and 3. Whoops. I have 3 and 3, 2 and 2, 1 and 1. Okay, these are called perfect squares. Okay, they make a perfect square. All the lengths and the sides are all even. So if I'm looking for a perfect square for 2 by 2, right? 9 is a perfect square because it's 3 by 3. So what I want us to do next is we're going to find the perfect squares that go up to 10. So I can draw this out if I wanted to, right? So 10, it would be, I would draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? And then I would have 2 times 5, right? 3, 4, 5. And then I could draw all of these out if I wanted to. But something that we noticed right up here is that we're using these numbers to multiply by themselves. So we've already found 3 perfect squares. We found 1. We found 1 by multiplying 1 by 1, right? 4 by multiplying 2 by 2. We found 9 by multiplying 3 by 3. So if we're thinking systematically and we're going to work through this problem, it would be easiest, instead of drawing them all out, to just keep that pattern going. Okay, 4 times 4 is 16, right? So the next one would be 5 times 5, and that would be 25. Okay, we can continue this process. So all I want you to do right now is just pause the video and go all the way up, find all the perfect squares to 100. So I've pause it now, and I'm going to keep going. So 8 times 8, 9 times 9. Okay, so now we have all of the perfect squares up to 100, right? Now, what about the number 0? I'm just going to put 0 up here, okay? Now, 0 is a very special number because I can't draw a square for 0. I can't do a 0 by 0 square, but mathematicians include 0 as a perfect square, even though there is no square that I can draw. So how they argue this, and you need to think really outside the box, very abstract, that a square with a length of 0 and a width of 0 has an area of 0. So it is a perfect square. 0 times 0 is 0. Okay? That is the argument for the perfect square, being 0. All right. So now let's go back to those prime numbers. Okay? So prime numbers have exactly 2 factors. So I want you to think about that. So they have 1 times themselves. So let's take a look back here. Okay? Now let's look for the prime factors. I'm just going to use green here. So 1 times 1, 2 times 1, 3 times 1, okay, 5 times 1, 7 times 1, okay, and then that's it there. So we have those prime numbers there. All right, so in our little chart here, what are those prime numbers? They are 1, 3, 5, and 7, right? Now, let's have a look at all those perfect square numbers. So you have 1, 4, and 9, right? 1, 4, and 9. Now, do any of them overlap? Can I put... Actually, a prime number, 1 is not classified a prime number because it's 1 times 1. Okay, so that's where I messed up. All right, so all of these numbers here are perfect squares. All of these numbers are prime numbers, and none of them have perfect squares. All of the numbers that are left out, 2, 4, 6, 8. Okay, none of these numbers have a perfect square in them either, and none of them are prime numbers. So these are all composite numbers, right? And they have something in common with perfect squares, but they don't match exactly because 1 in there. But most perfect squares are going to have a composite number in there as well. All right, let's make a generalization. So we can order perfect squares, right? So the way that I would write this as a perfect square, 4, would be, remember how we would put the 2 up there and it means squared, right? So I would put the 2 up there and it would be 2 squared. So all that little thing means is that I multiply it by itself. Okay, so I would have that perfect square, 2 times 2. This would be 4 squared. And now if I was going to compare 2 squared to 4 squared, do I have to multiply these out? No, because 4 is a bigger number. And if I had this square here and 4 times 16, this little square is going to fit in 1, 2, 3, 4, 1, 2, 3, 4. Is going to fit inside that square. So we already know that that's smaller. So if we were going to compare these, I would say 2 squared is less than 4 squared. Okay? All right, now, if I'm going to, so I can compare them, I can order them. Okay, do I need to keep them in this form? No, I can look here and I already know 1 squared is going to go there, right? And the next smallest is 2 squared, then 3 squared, then 4 squared, then 5 squared, right? And we can prove that right here. So they can be compared, they can be ordered. So our generalization about perfect squares, okay, just knowing everything that we know about them, what kind of rule can we say, or what kind of definition can we give to a perfect square? So number 1, they're whole numbers, right? And a perfect square is the product of a number multiplied by itself. So it is a whole number where we can multiply it by itself. All right, that's it.